right, so let's do this graphing secant and cosecant worksheet. And remember, it's really just sine and cosine graphs, and then we just have to put in vertical asymptotes and draw the curves of the graph. So when I see cosecant, I'm really thinking of graphing negative sine x plus 2. So there are a few things about that. I like to make a note to myself of what shape the negative sine graph is. So we have the period divided into 4 equal parts. The negative sine graph starts at the midline, goes negative, midline, positive, midline. So this is the shape of the graph. Now the midline, instead of being the x-axis, the midline is going to be y equals 2 because this graph gets shifted up 2 units. The period is 2 pi divided by 1, so 2 pi. Domain and range, let's do that after we get the graph. All right, so remember, you're sketching the sine curve, but your final graph will be cosecant. So I'm going to sketch the midline first. This part is optional, but I like to have the midline sketched in. And like I said, I'm going to sketch this shape here. So, all right, what was the period? It was 2 pi. Cut that in half, half, half. So I'm going to be placing my points above these tick marks, and I'm going to match this graph. So this sine graph with just open circle because it's not my final answer. It starts at the midline, and then it goes 1 unit below its midline because the amplitude is 1 on the sine graph. And then it goes, excuse me, back to midline, 1 unit above, back to midline. So this is one period of the sine curve, and then we need to make it a cosecant curve. So to make this section a cosecant curve, anywhere your graph, the sine graph would have hit 0, which is the midline, put a vertical asymptote through that point. So here, and here, and here. And then the actual cosecant curve shares the points at 1 and 3 that we have right here. And then remember, this graph has a reciprocal of every value on the sine curve. So its branches end up kind of flipping up like this. This is one period of the cosecant curve. Now I'm going to use the fact that it's periodic to just continue the pattern. And I'm going to do that across the entire interval here. So going this way. All right. And I'm going to fill in the rest of the vertical asymptotes as well. So I might as well finish out the positive side here. The order that you do this in is totally up to you. So I usually graph the whole sine curve, put in the vertical asymptotes, and I sketch in the branches at the end. So what I have in blue is the cosecant graph, and anything that's in red is just sort of like, kind of like a stencil or an outline to help me get the rest of the points. All right, anything that's below the midline, your graph should not cross through the midline for these branches, so always make them open away from the midline. You just do that for each one. We're not plotting any extra points on there. Just fit these curves to be about the width of the vertical asymptotes in between. So don't make it a lot more narrow and don't let it cross through. All right, now what about the domain? So the domain is no longer all real numbers. It's all real numbers. X can't equal. So we need to come up with an expression to talk about these asymptotes. This one's not too bad just to look at and see. They're just multiples of pi. 0 pi, 1 pi, 2 pi, 3 pi, and same on the negatives. So like we said in our notes, for the cosecant graph, you would say x is not equal to pi times k, and k is an integer. This is the shorthand for that since I don't have much room to write it. What about the range? From the graph, I can see the bottom branches go from negative infinity up to positive 1. And then the top branches start at 3 and they go up to infinity. All right, so that graph is finished. Let's look at the next one. This one is y equals 2 times secant minus 1. So this is going to be 2 times cosine x minus 1 as the graph that I outline. And again, I like to write, what does a cosine curve look like? So once you divvy the period up into 4 equal parts, cosine graph starts at its amplitude, hits midline, below midline, midline, above midline. We're going to move down 1. So the midline is y equals -1, and I'm going to draw that in. Next thing you need to find is the period. There's a 1 in front of the x, so the period is 2 pi divided by 1, so just 2 pi. Divvy up the period, or mark off. I like putting these tick marks here so it reminds me how often to plot the points, for the first period anyway. Okay, and because the amplitude on the cosine graph is 2, we need to make sure we plot the points correctly. So the cosine graph normally starts at its amplitude. So the midline's here, should be 2 units above the midline. And then we go to 0, or go to the midline, and then we go 2 units below the midline 2 units above. And I probably should have done dotted, I forgot. It doesn't really matter though. I'm going to use a different color for my graph. So far, one period, of the secant graph has vertical asymptotes at pi over 2 and 3 pi over 2. There's one full branch right here in the middle. And then right now I just have sort of half of a branch, but this will connect to the next part. So, all right, so graphing the rest of it. Now I draw the rest of the cosine curve, but you could also just start putting in the asymptotes and drawing the sketch. But I just like to keep going with the pattern. I find that if I skip too many steps, I just tend to plot the points in the wrong spot. I think it's easy for me to do. It's not, maybe that's just a me thing. But yeah, if you can get to just doing the asymptotes and just the branches, as long as you still have the one point that I want on each branch, that's totally fine. All right, so let's put in the asymptotes anywhere that the cosine graph would have points at the midline. So I'm putting all of these in. And sketching in the branches. So I'm just going to start on the left here and sketch in branches. Like that. This part gets a little tedious. It's easy to rush through it, so just try not to make it too sloppy. And put arrows on all of those branches. Okay, so there's our second graph. Let's go on to number 3. So number 3, this one does not have a different midline, so that's kind of nice. We're going to imagine that we're graphing 1/2 sine of x over 2 to begin with. So I remind myself that a positive sine graph starts at 0, 0, goes above the midline, midline, below the midline, midline. The amplitude is only 1/2 here, so that's where the max and min is going to reach. So the period is 2 pi divided by 1/2 because of the value in front of x. So that's actually 4 pi. And this is nice for us. It means we have less, I think we have less graphing to do or less curves to sketch. So let's, because there's no midline to draw on, let's divvy up the period right away. Put a mark at 4 pi, put a mark at half of that, put a mark at half of that, and halfway in between 2 and 4 pi. All of those tick marks remind me where to put my points. Domain and range we'll do when we're finished. So cosecant curve, the sine curve, 0, 0. And then at pi, we're at the amplitude 1/2 unit above that midline. And then 0, -1/2, 0. Same thing to the other side. So I need to put these marks in here every pi units. So if it confuses you to go backwards, sometimes people mess up the pattern that way. You can also pretend like -4 pi is your new 0, 0 starting point and say, all right, sine curve will go here, and then at 1/2 unit, and then 0, and then -1/2 back to 0. Anywhere the graph crosses through the midline, which is the x-axis this time, we put a vertical asymptote. So there's a wider space between these branches. We're going to make sure that we fit the shape of the branches into that space. So we have a point at positive 1/2. And then, yeah, just kind of remember, we're getting these values. If we were plotting accurate points, we would be reflecting, or we would be taking the reciprocal of a fraction here, and it would hop up just a little bit. So anyway, just try to fit it into the width of the asymptote. I wouldn't give you full credit if you just did something like that. That's too narrow. All right, so you're only having to plot 1 point on each branch, so don't be too lazy about it, basically. That one's even a little bit iffy, but that's okay. Okay, what about domain and range? So this one I can see, oh, did I do domain and range on the last one? No, sorry. Let's go back here, domain and range. I see these at all the odd pi over 2s. So all reals, x can't equal. There are two ways to approach this. Pick one of the asymptote values as your first value. I'll say pi over 2. Add to that the distance between this asymptote and the one next to it. So however you want to do that, 3 pi over 2 minus pi over 2 is pi, or from pi over 2 to negative pi over 2, that's pi. So you're adding pi k, and k has to be an element of the integer number set. Or remember, you can also just solve for this. This is our original, I guess for this one, this is our original set of asymptotes for secant that we had in our notes. So if you also just kind of memorize this, this is a good starting point. And then the range for this one is negative infinity to negative 3. And then the top branches pick up from 1 and go up to infinity. All right, sorry about that. So what about domain and range of this one? I see 0, 2 pi, 4 pi. Next one will be at 6 pi. So all real numbers, x is not equal to, so they're multiples of 2 pi, right? 2 pi k. K is an element of the integer number set. What if you're not sure on that, or what if you just want to do it a different way? So you can set x over 2 not equal to, where is sine normally hitting 0? At 0 and at pi and 2 pi. So sine is normally 0 on all the multiples of pi. Oops, not n, sorry. So we could say, or again, we had this in our notes, we could say pi times k, and then solve this for x, so multiply by 2, and you get x is not equal to 2 times pi times k. So whether you do this algebraically or you look at the graph, it's good to have both skills, because they might ask us about domain and range of a trig function, and we might not really want to or have time, or might not want to sketch the entire thing formally. So it's just kind of nice to know that. All right, 1/2 to infinity for the top branches. Okay, number 4. So let's think of this first as y equals negative cosine of 2x. The negative cosine graph, divvy up the period into 4 equal parts. It starts below the midline, midline above, midline below. The 2 there means that the period is 2 pi divided by 2. So that's a period of pi. That means we're about to have a lot of little branches to sketch. And if I'm doing this, I'm going to take pi, cut it in half, cut each of those in half. So we should have a point every half of a box here. All right, so the cosine curve starts at negative 1, because that's the amplitude is 1. Midline, 1, midline, negative 1. And instead of drawing in the vertical asymptotes here, let's just keep going with this. So you might want to divvy up each little section of pi so you don't miss a point. So midline, 1, midline, negative 1. So taking the time to do this means I hopefully won't have to erase points that I misplotted. Midline, 1, midline, negative 1. Now, if you don't want to do the tick marks, you could also say, oh, okay, so these are going to be all the high and low points, and then I just put some points in between. So you could do that. You could say high, low, high, low. This is periodic. Go above and below, and then go back and remember to put in the little halves. You could do that too. And again, maybe you just decided to go ahead and go in and plot the high and lows and just put vertical asymptotes where I just put all those little zeros. It's up to you. There are a lot of different ways to approach this, but when I'm grading it, I just am checking that you have enough periods to fill the window and you have the vertical asymptotes in the correct location and that the branches are starting at the correct point and fitting into the vertical asymptotes. Let's sketch the branches for this first half because it's starting to make my eyes buzz. So, all right, so here we are here, and we're opening down. Here I'm opening up, opening down. Just continue this on. Now, as far as I know, for the AP exam, it could be that we're presented with a graph like this, and then we have to pick the correct equation. But I think that's made a lot easier when you know how the graphs are generated. And sketching some of these graphs will be useful for us when we do application problems involving graphs especially. So I'm filling in all the vertical asymptotes. Anywhere the cosine graph has a point on the midline, because that's where cosine is equal to 0, and 0 has a reciprocal of undefined for the secant value. All right, so putting this in, sketching the rest of these. We had that question of how many periods should you be able to fit in here? Well, the span here is 8 pi. 8 pi divided by pi, that's 8 periods of secant that we're sketching. Kind of a lot, but it gives you a good sense for how the numbers in the graph are affecting the spread of the graph. All right, there we go. Remember, all of your graphs should start and stop with the same behavior. So the fact that I ended below at both the beginning and the end is a good sign. What about domain and range? Domain is always all reals except x is not equal to. So these are all at pi over 4s, but not every pi over 4. It's pi over 4, and there's a distance of pi over 2 between them, right? Pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4. So that's a difference of pi over 2. So you could say pi over 4 plus pi over 2 times k, k's, which is our nickname for k as an integer. What if I had to do that algebraically? I would say, all right, I've got a 2x. I'm going to set that equal to the original secant asymptotes. Secant, or cosine, is 0 at the pi over 2's. So the original formula that we have from our notes is, okay, regular secant graph has asymptotes at pi over 2 plus pi, k. And if you divide everything by 2, you get this expression I have here. Pi over 2 divided by 2 is pi over 4. This becomes pi over 2 times k. What's the range? Negative infinity to negative 1 and 1 to infinity. All right, 2 more graphs. Oh, this one's going to be another 8 period one. Our last one is not, so we'll end on a easier note. Okay, so last cumbersome one here. We have y equals 2 times sine of 2x minus 1. So this has a few things going on. First, it's a sine graph. So when you divvy up the period, it's going to start at 0, start at the midline, I should say. Then it's going to go up to amplitude, midline, amplitude negative, midline. The midline is y equals negative 1. I'm going to draw that in before I forget about it. Okay, and the period is 2 pi divided by 2, so it's pi again. So we're going to divvy up pi into 4 equal parts. And then when I sketch my sine curve, I'm going to start on the midline at that 0 at the y-axis, so midline. And then the amplitude is 2, so we go 2 units at the next tick mark, which is pi over 4. We go 2 units above the midline. and then back to midline, 2 units below, so I'm at -3, and then back to midline. Okay, now keep going with that. So either plot points every half unit, so up here, midline, down, midline. If you can keep track of that, then keep going. If not, then put the tick marks in. Like you could say, okay, there's got to be a period falling every half unit like this. That visual is a pretty nice reminder, I think, of where you're supposed to be plotting points. Let's do the same thing here. So what if I do that here? So, all right, so this graph goes down, midline, up, midline, down, midline, up, midline. I'm trying it without my tick marks. It's kind of tricky. Down, midline, up, midline, down, midline, up, midline. Okay, I think I did it. And then I'm going to put in the vertical asymptotes anywhere there's a point on the midline, because that represents where sine x is equal to 0, which represents where cosecant x is undefined. Oh, I'm missing all kinds of asymptotes, aren't I? I was skipping every other. I wondered why I was going so fast. This looks better, doesn't it? There we go. Okay, marking these in. Basically, you have an asymptote at every vertical box here, right? At every unit that's marked off. Okay, last thing is to draw in the branches. I'm okay with you drawing them kind of small. These do continue on. You know, I could draw them all the way up, but that would make this process even more cumbersome. So let's just do little sketches like this. And remember, these are not parabolas because the relationship on these curves is not an x squared relationship. So even though we're seeing that curve, it's easy to want to call these parabolas, but they're really not. Like I said, this is our last kind of annoying graph because the period is so small. And my rule is that I would like you to graph as many periods as you can fit across the window that I give you. So there's that. But we can do our domain range, and then our last graph is a horizontal stretch instead of shrink, so it should be good. All right, what are these asymptotes? Now, these are every pi over 2, right? Every box represents a pi over 2. 1 pi over 2, 2 pi over 2, 3. So we can say all reals, x is not equal to pi over 2 times k. K is an integer. K is an element of the integer number set, which is represented by a z. If you wanted to solve for that algebraically, you would say 2x is not equal to, sine normally has its zeros at pi and 2 pi. So you would set that equal to pi k and then divide by 2. So that's where that comes from. What about the range? We've got negative infinity to negative 3 and 1 to infinity. All right, last graph. This one should be modeled after a cosine curve and a negative cosine curve at that. So we're going to be thinking, we're going to be maybe off our grid a little bit here. Let's see. A negative cosine curve, when you divvy up the period into 4 equal parts, starts below the midline at the amplitude, midline, amplitude, midline, amplitude. The midline, because the graph is being shifted down 1, is y equals negative 1. So sketching the midline first. The period is 2 pi divided by 1/2. So 4 pi. That's what we like to see because that means we won't have as much to sketch in. So mark off the end of one period at 4 pi, cut that in half to 2 pi, cut that in half, and put in the halfway mark between 2 and 4 pi. This represents where you're going to be placing your points. And then follow the pattern for the curve. Remember, this is your midline right here. So you start 3 units below the midline. So 1, 2, 3. Oh, we'll just fit. So you're at -4. And then, and it's supposed to be the outline graph. And then at pi, where the next point goes, you should be on the midline. At 2 pi, you should be 1, 2, 3 units above at 2. At 3 pi, back to midline. At 4 pi, down to -4. Continue that pattern. So you're going pi, 2 pi, 3 pi, 4 pi in the negative direction. And you can continue this on. So midline, 3 units above midline, midline, 3 units below. Draw in the vertical asymptotes where the graph hits the midline, which is where secant is undefined, and cosine is equal to 0 on those points. And then sketch in the branches. Now these branches, I guess, are a little bit off, but just sketch a half branch here. And these branches are pretty wide, like we did. We had one of these graphs earlier in this assignment. And just kind of keep them fitting fairly wide to the curve. I do want you to sketch in the half branches because those are parts of the graph that exist between -4 pi and 4 pi. The domain is all real numbers. X can't equal. We're at pi, 3 pi. The next one will be, there's a distance of 2 pi. The next one will be 5 pi, 7 pi. So we have all the odd pi's. Now, you can do this. You could say pi plus 2 pi k, right? Or you could say pi, factor out of pi, times 2k plus 1. 2k plus 1 will give you odd numbers, k's. If you had to solve for this, what would you do? Well, it's x over 2 can't equal. What are the original cosine values? They're undefined at pi over 2 plus pi k. And so if we multiply by 2, we do get pi plus 2 pi k. So that's where that comes from. The range is -infinity to -4 and +2 to infinity. It takes a bit of practice. These might take you a little bit longer than your sine and cosine graphs because we have those couple of extra steps. But the bulk of the skill is still in getting the sine or cosine graph. The rest is just sketching in the final pieces.